Welcome to 5G Technology World. I'm site editor Martin Rowe. Recently, Qualcomm, Ericsson, and US Cellular installed a fixed wireless access 28 gigahertz mmWave system in Wisconsin that brought high-speed internet across 5 kilometers from a cell. Such distances have the potential to make internet access available to people in many areas by reducing the number of cells needed to cover a given area. To learn more about this, we spoke with Mohammed Al-Kaheri, Staff Manager of Product Marketing at Qualcomm Technologies. Mohammed, thank you for speaking with us. Can you explain the significance of this installation?
It's significant in the way that it's actually redefined the perception that we have about mmWave technology. Not too while ago, a lot of skepticism about mmWave, can it be work or can it be done or used in a cellular system? And even when we start actually showing that and demoing that and even show that in the field and in actual product, there's still some questions about the range of the mmWave. Can it be used? Can it be not? What is about the coverage, the size of the antennas? Can you fit that in a small handheld? So we've shown all that. Actually, it was like a challenge for us, but it was basically we are up to those challenges. So we showed that in an actual end product in mobile devices. But then also we wanted to show that mmWave is not only suitable for that type of communication, but also for a fixed wireless access. So early on when the 5G came in, fixed wireless access was being talked about from a sub-6 perspective, giving the need for the long ranges for that link between the CPE devices and the network. And that being basically understood, that is more like the sub-6 kind of capability, not the mmWave. mmWave will be only, if it's being used for fixed wireless access, it will be only used for a high dense area, short distances, or urban deployment. Now, with this milestone, we're talking about over 5 kilometers, like it's 3 miles or so of a connection between that CPE and the network. And this is kind of a significant, this is a huge, because basically now you think of mmWave more of, it's a suitable technology to be used in fixed wireless access. And it's not only for urban or high density, you can use it for suburban, or you can even use it for rural areas. So it is a very good technology to be used for the last mile of connectivity. Now, you mentioned the 100 megabit per second. I wouldn't be too fixated about this number. This was not meant to be the capability or the limit of the technology. This is actually barely scratching that technology. This is, and actually the same week of this announcement, an analyst like Mike Philander from Signal Research Group, he went to that specific location and tested, and he was able to achieve 200 megabit per second. And I'm pretty sure, we're still working on that one. I'm pretty sure, in the near future, we'll even have multiple folds of these numbers.
What types of installations might come from this development, and where might those installations be located?
So the fixed wireless access in general, we do see that in different ways. It opens the possibility for different kind of use cases. Some of those use cases, you're definitely right. It's more targeting for the suburban and rural areas. Think of rural communities where they need to connect schools, where they need to connect government offices or hospitals, medical offices. So there's a lot of businesses, even local businesses. So there's a lot of needs there to be connected. But even in urban area or even suburban areas, so there are some use cases that you can use fixed wireless access for that one. So I wouldn't say that this is only for that. It's actually opened the possibility from urban to rural areas. So I would see that in a different, across the globe, not specifically in the US, but in US and across the globe, being used in urban, suburban, and rural areas.
What is a typical installation for the user equipment?
So the user equipment in this case is the CPE itself. So that device is the CPE. It is the one that is communicating with the network, and that is the one that has our modem RF system, and that is the one that is that we were able to show that is able to communicate with that cell tower over 5-kilometer connection. Now, after that point is basically how you take that connectivity, that service in home. So there's so many deployment that you can install that CPE. You can mount it on your window inside the house or on top of your house. So now if it's an outdoor unit, usually what you do, you basically run some sort of an Ethernet cable inside, and you would have some like wireless router, Wi-Fi router inside your house. And you would have all your devices connected to that router, and the backhaul would be, in that case, the fixed wireless access. If it's an indoor unit, usually that would be a fully integrated unit that has the 5G and the Wi-Fi as well. So we have one box that actually replaces everything in that case.
Does the wireless link support beamforming at both the cell and at the user location?
So the QTM527, which is the millimeter wave antenna module that basically support the extended range. That is a fully it's a full from basically the transceiver all the way to antennas. That does support all type of beam management, including like beam forming, beam seating, and everything. Yeah. Mm-hmm. So whatever we do support in terms of feature that you see in the actual smartphone devices, that is also supported on the QTN527, with the addition that you have more antenna elements, and it is designed specifically for the CPE, which has a different power class. With like the power class for the smartphone devices is more like power class 3, so there's a limit of the maximum power that you can transmit, whereas in the CPE devices, this is power class 1.
How many elements does the antenna at the user end support?
So in the QTM 527 that I just mentioned, we do support up to 64 antenna element, yeah, and you do need that amount of antenna elements, and the reason is basically the more of these antennas, basically the more you would have a narrow beam, directional beam, and the more you would be able actually to have a higher power as well in order to reach those kind of distances.
What are the different installation possibilities at the user end?
From a CPE perspective, we discussed like there are mainly, I would say, like 3 deployment scenarios in that case, if I may say that, is you would take that CPE, you would install it on top of your roof, mount it on your window, or just basically on deep indoor, and that would be basically like your modem, your actual modem or wireless router inside the house. So each of these deployment, it comes with, of course, different heights. Now, from a technology perspective, of course, like if we're talking about millimeter wave specifically, if you want to reach that, if you want to maximize the distance, the more that you have a line of sight, the better in terms of performance. But that doesn't necessarily mean that basically you have to have a line of sight. It does work in a non-line of sight. Of course, there is some sort of a trade-off between if you do that line of sight and no line of sight in terms of the distance and the capacity that thing can handle. But the higher the antenna, that indicates basically the more likely that you would have a line of sight between the CPE and the network, and then basically the better performance.
Does the bit rate vary based on signal strength? Or is it more like digital TV where it's all or nothing?
No, it's still more like the cellular. So the closer you are to the base station, the better the better signal you get, and by design you will get a better coverage, and that coverage will mean a better performance.
In this network, do base stations need a fiber connection to get back to the network, or is there a wireless possibility?
If you're a network operator and you want to install a base station in a rural area, so that base station definitely needs to be connected to your core network. usually that connection would be through fiber. So all your network is connected through fiber to maintain that high bandwidth and low latency, and it's basically high reliability as well. However, fixed wireless access can be one of the use cases for fixed wireless access is to connect those base stations. So instead of having like think of it, I'm an operator deploying here a base station. There's no fiber that I can connect to that base station. I'm still able to connect that base station to my network through fixed wireless access as well. So now fixed wireless access, instead of being now the broadband service to an end user, that would be the link or the backhaul that can connect base station to the entire network as well.
Was the Wisconsin installation the first of its kind to achieve such distances?
The interest, the traction in fixed wireless access is significant, and rightly so. You mentioned that the pandemic played a big role here as well. A lot of people working from home, so the need for a good broadband services, even for those who are connected, is basically skyrocketing right now. The traffic demand is skyrocketing, so just basically the need is basically unquestionable. From a traction perspective, if you look at a 5G, so today we have, I think, the latest number that we have for 5G deployment is we do have over 90 operator deploying or trialing 5G in 40 plus countries. And a lot of them also, they're planning to add fixed wireless access into their services, because it does make sense. You're using your own infrastructure and you basically add one more service to that one, especially if you have mmWave, you have that extra capacity that you can really use it or reuse it, use that spectrum to get more revenue and provide an adjacent services to your mobile service as well. Perspective devices, CPE device manufacturer. Last year, like September last year, we, along a 30 OEM, kind of announced that basically they're selecting our solution to provide CPEs. So you can see the traction, whether that from the demand from the consumer, basically they need a better broadband services, from the operator actually deploying 5G, and even from the CPE device manufacturer actually getting into this and trying to basically develop a wide range of product portfolios that can support like mmWave, sub-6 and everything.
Mohammed, thank you for speaking with us today. I'm 5G Technology World site editor Martin Rowe. Thank you for watching.